Does everyone feel like they're on track to getting this stuff installed? You have like the web page open so we can like get rid of this ugly link? Yeah? 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 Cool. Start. So, hello, good morning. Are you like feeling energized? Yes? Great. So, today we're here to tell you how you can take back control of your identity. Yay, this is exciting. Yay! Okay. So, like there's 3 of us here, so it's like triple fun. So, André is like, we're all from Portugal. André is the CTO at Moxie. Paul worked with him at Moxie as well. And I work at Mythex, which is a different company. But we have been all collaborating in this really cool project. So first, we're going to start with like a crash course in self-sovereign identity. And it's totally fine if you've never heard the term before. We're going to go over it. We're going to like introduce a couple of interesting topics. Then we're going to say like, okay, so how does all of this thing that we've learned come together? Like, what can we actually do with it? So there will be some hacking time at the end. We're going to build like a really cool application where like essentially you'll be able to identify the messages coming from everyone in this room. And it's all going to be super decentralized. Yay.
Hopefully.
Yeah, if the Wi-Fi cooperates.
Yeah.
So yeah. So first of all, we think that the current identity systems are broken. Okay, like they are no good. We need to make them better. So why are they broken? Like if we go back to our friends at Wikipedia, they tell us that identity is like the set of qualities, beliefs, personalities, expressions, whatever, that make you who you are. And this definition was pretty good like a few years back, but today, like your digital profile is a big part of your identity, right? And the problem is that like you don't really own those profiles and you do not control them. They're usually owned by these big corporations stored in these big data silos, completely opaque to you. And this is problematic, right? I mean, sure, if you went back 100 years ago, you did have total control over your identity, right? You don't want to like show your qualities or beliefs or personality. Like, just don't talk to people. Don't show yourself to people. You'll be completely private, right? But today, you don't really have that option anymore. So, I mean, you go on Facebook, you use an app, ta-da, surprise, your data has been used to sway the results of an election. Yeah, like, you go on Google to type stuff, or you talk to your friends, surprise, your data has been sold to advertisers, so now we know exactly how to target you. You use Equifax, surprise, your identity might be stolen for the rest of your life because we just need your social security number. So yeah, like right now in the US, there's 143 million people who need to spend the rest of their lives looking over their shoulder because their identities might be stolen. Yeah, not ideal, right? So essentially, since you don't control like how your data is stored, 2 things happen. Like, first of all, obviously you have no control. Second, since all of this data is stored in these centralized places, it's a big honeypot, right? It's just a big cash prize to try to get. It's a big target for an attack. So we don't want that. And obviously, like each website is its own login information. Maybe use a password manager, that's cool, but most people just write it down on a post-it and then they put it on their computer screen. It's a very hard system to maintain, not secure at all. So yeah, that's bad as well. And also, like, you can just be deleted, right? And this doesn't have to be like a 1984, like the government's against me scenario. It can just be like pure negligence. So I think it was MySpace just announced recently they lost 12 years worth of music. That's insane, right? 12 years. So yeah, like, and especially today, there are a lot of professions where your social profile is like directly correlated to your livelihood. So if that information gets lost, you essentially have no way to make a living. So this is like really important. So self-sovereign identity is like not the holy grail, but it's a really nice attempt at fixing some of these problems. So what is self-sovereign identity? So if we think back of identity systems over time, we started with like highly centralized things like ICANN, giving out IP addresses to people. Then we had the certificate authorities, which was like a hierarchical system, but also highly centralized. Then came like Microsoft with something called the Microsoft Passport. It was essentially a federated system, like really cool. You can take the same identity and log into multiple places, but Microsoft owns all of it. Not ideal either. Then came like OAuth and OpenID, which were supposed to be like really cool and decentralized, but then they just ended up being too complex for normal people to implement. So they just went back to cloud providers, super centralized again. And this led us to like a big community-driven effort to develop standards on self-sovereign identity, which is essentially a type of identity system where the user is put in control of their data. So it is self-sovereign because the user can just take their data and move it to a different system. And you can do that as many times as they want because everything is standardized. Every system understands the other providers, right? So yeah. So how do we actually implement self-sovereign identities? There is something really cool called decentralized identifiers, or DIDs. Has anyone heard of DIDs before? Yeah. Oh, cool. So like, we can just blaze through this. Nice. So, the keyboard didn't work. Cool. So a DID is just like a global unique identifier. So it's got like a protocol and then a namespace and then a unique string that identifies it. It's persistent. It has no central registration. And most importantly, can be globally resolved. So anyone can take a DID and actually turn it into something meaningful. For instance, in this case here, this DID, this string here is using the DID method example, and we'll go over what the method means in a while. And then there's like a specific string that resolves to this document here. And this document essentially gives us the required information to establish a cryptographically verifiable channel of communication with that person or that entity, right? So in this case, it has like a public key there, and then it says that for authentication, you should use that public key. So I give you my DID, you resolve it to this, and now you know which key you should use to authenticate against me, right? The way that you take a DID and you turn it into a DID document, by the way, this is a DID document, not sure if I said, but yeah. The way you do that is through the DID method, which is a specification that defines how the create, read, and update informations happen for that specific method. So what this means in practice is, for instance, we have the DID method IPID, which is based on IPFS, which essentially says you take the method-specific identifier, you go on IPNS, that resolves to a CID, you get that CID, and then boom, you have the DID document. Really cool. But maybe you don't like IPFS, maybe you want something like super strong, like stored on Bitcoin or something, and we also got you covered. There's something called the BTCR method. So you take this string, you decode it, this points to a Bitcoin transaction, and then you go on the op return field of that transaction, and there will be like some pointer to storage, which points to your DID document as well.
By the way, the author of IPID is
Johnny Crunch.
It's Johnny Crunch.
I didn't know if you wanted to remain anonymous, so I didn't say anything.
Special guest appearance just for you.
Yeah. So essentially, like, just wrapping this up, the DID thing very quickly. A DID infrastructure is like a key value store. So your key is your DID, the store is your DID document. Yeah, so the DID method defines how everything happens for that specific DID type. And then there's just like a little summary of a bunch of DID methods that exist. What you can see is that like some are based on Bitcoin, some are based on Ethereum, a couple are based on IPFS. I think I've heard of a new one sometime this week. There are some with their own blockchain, which was just like a blockchain created specifically for that purpose. So like it has better features just for the identity purpose. So the IDs are pretty cool, right? But we started by complaining about Google and Facebook, and these are applications that are like feature rich. They offer a bunch of stuff. And here we came up with a solution which is this, yeah, now you have like a cooler version of PGP. So that's not really a solution. So that's where verifiable credentials come in. So verifiable credentials are like essentially a fancy term for a message that can be cryptographically verified using a DID. So you take a message, you sign it using a key that is in your DID, then you slap that DID on that message. So now anyone can come here. For instance, this is a claim that the government could issue to me saying that I'm over 18 years old, which means that I can like go into a club and just show them that I'm over 18. They don't need to know my birth date, which is pretty cool. So the way you verify this is like, so you have your signature here, you have this DID here, which in this case would be the DID of the government. Everyone would know it would be like one of those that are very well spread out. Yeah, very publicized. And then so you just go here, you get the key one from the government's DID, and then you can verify that this message is authentic. Right, so that's how the flow would work. So DIDs and verifiable credentials like work very well together. Essentially, at the end of the day, what you have is a decentralized layer of identity, which in turn allows you to build a decentralized layer of messaging. and just exchanging meaningful information between parties. So, like the bottom of the stack, we have decentralized ledgers. Then on top, we have built decentralized identifiers, and then we have the verifiable credentials on top of it. And now it's up to all of us, like the developer community, to build awesome, amazing, great stuff on top of verifiable credentials, right? Because if we are able to do that, then we can compete with like these big platforms by offering the same type of features that users really want and need. Like users don't really care about verifiable credentials or whatever. You just need to give them really cool stuff using this really cool technology. And that's kind of what we're here to show you today, like really cool stuff that you can build using what already exists today. So, right? I mean, come on, that was, like, just do it again because I think it's worth it. Like, right?
You actually see the wave from
the wave from the screen. We were like burning the screen yesterday to make it wave. So like,
nice
Thank you, João, for your amazing introduction. So, hey guys, what we have today is that developers, to ease your life, they have like multiple single sign-on with multiple providers, so that you can use your Google account or your Twitter account or your GitHub account to sign into a website, for example. But what this means is that they need to set it up for every single one of these providers. And although the IDs and verifiable credentials are meant to be interoperable, we are starting to see something similar with what we have today. So we are starting to see different or separated ways to sign in with different wallets. And to do this, developers will need to keep in mind that there are different wallet SDKs and that there are different DID methods, so they'll need to implement every single one of the SDKs if they want to embrace all of the users, right? So, unfortunately, we know that there are some constraints, and time is one of them, for example, and developers might not implement every single SDK in their app. So what would happen? Imagine our friend here, Rick Sanchez. He wants to sign in into 3 different apps, and each single one of these apps only supports signing with a specific DID method or with a wallet. So for example, the first app uses Uport, the second app uses Blockstack, and the third app uses Jolocom. So what Rick Sanchez will need to do is he will need to create his identity 3 times, replicated with three different DID methods, and he will use that to sign in into the 3 different apps. But imagine now that Rick Sanchez has a minor daughter, and he wants to create an identity for his daughter. So, and he wants to use that identity to also sign in to each one of these apps. He would need to replicate his daughter's identity 3 times again to sign in. So imagine the pain that it will be to manage all your identities like this. So, keeping this in mind and these problems, Identity Manager arose. And Identity Manager, what Identity Manager is, it's like a way for you to have or manage multiple identities created or with multi-DID methods, and you will be able to manage all your identities with Identity Manager. Identity Manager is a work in progress, keep in mind. We have been working on it like 4 or 5 months, and our vision is to support every single thing that you see on this slide. So for example, we aim to support DIDs, verifiable credentials, single sign-on with DID Health. We aim to be multi-device, so that you can use in your mobile phone, laptop, desktop. We aim to provide the way for you to sign any arbitrary data that an app might require. We aim to have all your identities data encrypted within the wallet. And we also aim to be compatible with an arising API called Credential Handler API that enables a website to request users' credentials. So, in this slide, you can see an overview of the architecture of the Identity Manager. So, for example, imagine that we have an IBM wallet UI and we have an application, but they want to communicate with each other. how would you do that? So the IDM wallet UI would use the IDM wallet SDK, and the application would use the IDM client SDK. These SDKs could be configured with bridges. And what are bridges? Bridges are a way for you to communicate, or bridges create a channel for the application and the IDM wallet UI to communicate with each other. So imagine this. The IDM wallet UI is being run on the browser, and the application is also being run on the browser. So they could use like an IDM bridge with post message. So they would communicate with each other via post message. But this is dependent on multiple factors. So for example, imagine that you carry your wallet in your mobile phone because it's easier, right? You have your mobile phone with you all the time, and there is an application on the browser in your laptop that wants to communicate with your wallet. So post message wouldn't be viable. So we will use another type of IDM bridge that is based, for example, in P2P. So, presenting Nomius. Nomius is the first identity wallet based on the identity manager specification. It uses the JS implementation of the identity manager, and I would like you to go to this demo.nomius.io and follow the steps that Andre will show you.
So let's all open this website here. So this is like a quick deploy of the recent version of Nomius. So if you open that into your browser, I will do a quick follow through all the features, and you can do this with me because we will need to create your identity so that you can interact with each other in a chat app. Okay, so let's follow through the steps really quick. So the first screen that you see is the setup locker feature, which basically is a way to set up one or more lock types for everything within the wallet to be encrypted. In this case, we support passphrases for now, but we aim to support Touch ID or Face ID or whatever the hardware provides us to have more user-friendly locking and unlocking types. But for now, we just support a passphrase, so let's type something that works. So continue. The next step is the expiration time. So if you are idling within your computer, after that amount of time, the lock screen will be visible and everything will be locked. So let's choose like 10 minutes for now. By the way, are you following through? It works? Yeah. Oh yeah. So one thing, please use Chrome and Firefox. Safari doesn't work yet because we have to make it compatible.
Is Brave okay?
Brave, okay. Probably yes, because it is Chromium, so I guess so, yeah. But I haven't checked it, so. So this is like a landing page, it's not final, but we can create an identity, which we'll need for the workshop. So you can either create or import if you already have one, but for now I don't have it, so let's create my first identity and do that as well. So we can choose between a person, organization, or other. Why is that necessary? For instance, you can have your cat, and your cat can have an identity, and it should have, because you can store vaccines, for instance, credentials that state that they were vaccinated, so they can be stored in the wallet as well. But in this case, I guess I'm a person, so I'm gonna put my name now, and I'm gonna upload my photo, which can be this one. Continue, and now you are setting up the device. So as Paulo said, we are multi-device, so it means that we can have 1, 2, 3, 4 devices associated with your identity. So I'm here creating my first device. In this case, it already automatically detected that I'm on a laptop. So let's keep it. And it's been created. So right now we just support IP ID, but we want to support more DID methods. So what's happening now is that my identity based on IP ID is being created. So it might take some time depending on the internet, I guess.
Yes, oops, looks like something went wrong in the field.
I couldn't hear, sorry.
It says that something went wrong.
On this step. I guess it's the internet on maybe. Yeah. Let's retry.
Go
met the issue?
If no, we can change the network.
The same issue.
I'm not. Oh, so I move to the backup Wi-Fi?
Yeah,
So we can C.
backup C, and the password is share, capitalized, with, also capitalized, IPFS, all in uppercase.
Okay, let's try now.
I think share with the first.
Sorry, what was the problem?
Yeah.
Hi. It's not letting me continue.
Mhm.
So I keep clicking on this one. But this
Maybe still not working. Okay, I was successful within the backup.
There, if you guys need it.
Got it. After this, I re-sign up.
So at least in this network I was able to create it, so you should be able to do that as well. It takes some time because it actually uses IPNS and stuff like that, so it's still and also it uploads your avatar, so it takes some time, depending on the network, of course.
I have a quick question while people are getting set
Yeah.
up. So is that actually updating the DID document?
Yeah, I will show you right after. I will actually show the DID document with the public keys and stuff like that.
There's no encryption layer on top. There's no. It's in the clear on IPFS.
On IPFS, like the data that is within the
Everything
storage.
inside the DID document is in the clear.
So yeah, it's unencrypted, and it's supposed to be because there's no sensitive information there.
Yeah.
Because there's just public keys there. There's no meta information about yourself. That's the job for verifiable credentials. So you could have like a verifiable credential saying your name, and you could sign it with your own public key because you are saying my name is X, and you'll be signing that with yourself,
The
with
DID
your
is
own
just
keys.
just a presence and a set of keys.
Yeah,
Really.
yeah. Are you able to create now with the network? Yes? Cool. So let's keep going. So I'm going to go through to the backup identity flow so that we can import this identity in another device. So let's just go really quick. So what happens here is that in the case of IPID, the master key controls your IPNS record. So that's if that gets stolen for some reason, you're pretty much in a bad situation because anyone can then change your DID document forever, basically, at least for now. So you need to back it up really safely. We are using paper keys. At the moment, we don't support PDF, but we will. But we have to do it manually, which basically is a mnemonic, 12-word mnemonic. I'm just going to copy that to, like, can be here, like in the console, I guess, and maybe here, just to be safe. And type continue, because now I'm going to get a confirmation step. So I need to select the number 3, 1, 2, 3, salon, and the number 6, 1, 2, 3, 4, 5, 6, antenna. Yeah, okay. So yes, so what happens is now my master key was removed from my local wallet, and is now cannot be recovered using the mnemonic, right? So let's actually try to import this identity in another wallet, and just to demonstrate that Nomius is just a user interface that anyone could implement their own user interface. Let's use like a real drafty wallet that we did yesterday, just for the demo. Okay, maybe I should clear the storage because I don't remember the passphrase for this. That's why we want to have Touch ID and stuff like that, right? To be more user friendly. So yeah, this is something that Paulo made yesterday. Hopefully things will be able to work. Like, so this is like a very rough IDMO-like wallet. I have no identities, of course, so I will take the mnemonic, which is here, and I'm going to import it, right? So I'm going to paste it and submit it. This might take some time. Hopefully it will work out. Let me just check the network to see if things start to pop up. Okay, it seems to be working. So it goes over IPNS there. And now it's getting my avatar as well. Yeah. Yes. So I was able to import Andrecurus from the Nomius wallet to another wallet, right? So this is just to showcase the interoperability between the wallets that follow the same specification, right? So let me just continue with the demo. Let me just close this tab, this is a whole tab. So let's edit my profile, right? So let's complete some fields. We can choose our nationality. I'm male, and location, something near Spain, I guess Barcelona or something like that, not sure. So the internet's, okay, cool. Right, so as you can see, I already have the information here, and it should be replicated there automatically, right? So both wallets are devices of the same identity, and all the information flows between identity seamlessly using peer-to-peer based. Yeah.
I took the DID.
Yeah.
And if I understood well, this is an IPNS name, so I tried to resolve the name.
Yeah, you couldn't. It's not. It's normal. I will try to explain that.
Okay,
so, if you take your IPNS record and try to resolve it through the gateway or something like that, you want to be able to, because we are using a fork of IPFS that uses a multi-tiered data store for IPNS record. In this case, we are using Cloudflare workers and DNS, IPNS over DNS, meaning that if you go to the gateway is not using those right now, so we are not able to resolve it. We had to do this because IPNS in the browser is still not available because the DHT on the JavaScript implementation is not yet available, but it will be. So we can then switch over to DHT-based IPNS, and things should work out.
I understand.
So let's actually open my DID document. As I don't know your name. What's your name? Okay. As you said. So let's try it out. So we have like a cool variable here, which is exposed. I will increment my font size. We have like that variable, which is exposed just for development purposes. In this case, it's a demo. So we have like, this is part of the specification, by the way. So we have like the identity scope, and we have the list function to list your identities. In this case, it's just one, so I'm going to access 0. And let's grab my DID, right? So my DID is that one, which is based on IP ID. And if I try to resolve it, not through the gateway, but through the same tier store that I've spoken, we have like a different scope for that, which is DDM, and we have resolve, and let's put the DID, and because it's a promise, I need to wait for it. Take some time, I guess. The internet is really flaky. Like I was like 10 minutes ago, and it worked really fast. Go ahead.
Are you using the DAD resolver JavaScript code implemented by UPort?
Yeah, so they have like not the universal DID resolver, but they have a pluggable. Yeah, we have a module for IP ID that is able to resolve through that model. Yeah, we're actually using it. By the way, if you are interested in the code base, we have like I can show you afterward, but we have like an index of repositories. One of them is a module that you can use with that resolver. So this is the DID document, right? So it's very similar to what João showed you. And in this case, we have 3 public keys because I already imported it in 2 devices, like the example wallet, this wallet, and also we have the master key listed here as well, which is the one that controls the IPNS record. So to show you the names of the keys, let me just put that larger. So the first one is called IDM master. The second one is called IDM device and the hash of your public key. And the second one is very similar, IDM device and the hash of the public key, right? And also I'm stating that my 2 devices are able to authenticate throughout the web, I guess. So this is just a quick demo of the overall features of Nomius. I think I don't have any more stuff to show you right now, but I will after the workshop. So let's actually start the workshop now. Does anyone have had problems installing the workshop? No? Go.
Quick question.
Yeah, go ahead.
Do you have stickers for Nomias?
Oh, not yet. Not yet. But that's a good suggestion. Perhaps next time I will, or I can mail you some. But we need to make those first.
Cool logo.
Yeah. Okay, so let's follow through the workshop. So we have here the full workshop, but I will do it with you so that we can walk through and I can explain what's happening. So we have like 10 minutes, I guess. So it's going to be real quick, I guess. So let's start by setting up the IDM client, okay? So I'm going to just copy the code that we already have here, and I will try to explain really fast. So the first thing that I want to know about this app is that we have the index.js file, which is this file, which just configures IPFS node, because we need IPFS for the pub/sub room, for the chat, and also you need to understand that we have stores. We have the user store, which manages the user, the current user, and has login and logout functions, and we have the room store, which basically is responsible for managing the room state, like the messages and sending messages and verifying messages. So let's start by actually adding the IDM client. So let's just copy that at the top. And I'm going to do this really quick because we're out of time. So I'm pasting the import from IDM client and from the bridge post message, because we are using wallet within the browser and we are using the app within the browser as well. But in the future, there will be other bridges. For instance, we can have a bridge based on libp2p to have connectivity, ubiquitous connectivity between devices and between apps and wallets. And now I'm configuring the wallet URL that will be used for the post message bridge, and I'm declaring my app there, which has a name, and optionally it has a home page and an icon as well. So let's keep moving. By the way, you can check the README if you are falling behind. Is everything there? So next on, I'm going to change the setup function to include initializing all these libraries. So I'm going to put here after the IPFS node creation. So what's happening here is that I'm creating a client-side bridge with my wallet URL. In this case, is Nomius. And I'm also creating the IDM client with the app that I've declared, the manifest of the app, basically the bridge, and also the IPFS instance, because as we use IPID, we need also IPFS to resolve the IPNS records for the identities. And also, I'm configuring the stores by now passing the IDM client. Okay, you can erase this line here; it's the same, but now we're passing the IDM client. We'll use it in the stores. That's the first step. The second step is to actually add authentication, right? And by the way, let me just show you the current state of the app. By the way, it works right now. So if I log in, I'm logged in with John Doe, because we haven't yet integrated IDM client. You can already type messages, right? I don't know if you are seeing my messages there, but it should work. Yeah, John Doe. So as you can see, the signatures there are invalid because this is a dummy signature. We are not using anything to create signatures. So our goal now is to add authentication, so that instead of John Doe, we'll be putting our real names and our real photo there. So let's keep moving. The second step is to go into the stores /user and get hold of the IDM client. So let's copy that and go into the user store. Just replace the configure function with that code. So what's happening here is that I'm using the IDM client to subscribe to session changes. Let me try to explain quickly what a session is. A session is a connection between a wallet and the app. So that's called a session. Essentially, whenever you authenticate, you have a session that contains a session ID, contains the user information that app requested, and some other fields like the profile details that are basically the profile name, the username, the user avatar, and stuff like that. Actually, we have more fields, but they are not needed for now. So yeah, I'm basically copying that and dispatching a change for the React app to automatically update. So next on, what I want to have is to actually rewrite the login and logout functions that are on the store to use the IDM client. So let's copy that. And instead of having all these dummy functions that we have there, let's replace with the code that we have there. So basically what's happening now is that I'm calling, for the login function, I'm calling the IDM client.authenticate. This will prompt the user to authenticate, to authorize the app to receive some information about the identity, and it will return a session. For the logout, is really the opposite. You ask to unauthenticate, and the session will be destroyed, basically. So let's try it out. So go to the example setup. Let's log in with IDM. So this is the post message bridge. So if you're able to unlock, you'll see the screen. So this app wants to authenticate you. Example setup. And you'll receive the social details and social proofs. Social proofs are not yet implemented. They will be shortly. So the app will just receive my personal details. Also, you'll be able to edit those details in the future. Like you could fine-grain tune the details that you want to disclose to the app. So after I accept, I should be logged in, and I already see a message from Alan Shaw.
Yeah.
Hello, everyone. Cool. So did you receive it, Alan?
Yeah.
Okay, we have another message from Gregory. So it seems to be working, but there's an issue, right? So the messages are not being signed. And let me just recap that. There's another issue, which is if I refresh the page, I will lose my session, right? Why? Why is that? Because I don't have code yet to resume a session. I need to actually do that. It's really simple. So I just need to check if I'm already authenticated on the Bootstrap, right? I need to copy this piece of code into the configure function here. So I'm checking if I'm already authenticated, and if I am, I will grab the profile details from the session. Okay. So just this change. If I refresh it now, so it's this one, I should be able to be logged in again. Yeah, it works. So next step is to have signatures, right? This is the awesome thing. So let's do that. In order to have signatures, of course, we need to do that in the room store. We need also to grab a reference from the IDM client because we'll be using it. So let's go into the room store, and let's go at the top where the configure function is, and let's just paste it here like that. So now we're just holding a reference to the IDM client. It's really just a reference. And now what I want to do is to actually sign the messages within the chat, and also I want to be able to verify the messages from others. Basically, those functions will be automatically called by the React app, so we just need to change them. So let's copy this line over here and replace it with the dummy signature here on the line 110, right? So now those messages will be signed, and also let's copy the verification of the signatures to the function below. Just remove like the fake promise and the fake result with that line of code, right? So let me try to explain what's happening. So on line 110, I'm asking the IDM client to sign without options, to sign the message, which is the JSON. And then after it succeeds, I will broadcast the message which contains a signature. Whenever others receive messages, they will be verified, right? So I need to extract the original message without a signature and ask the IDM client to verify if the signature is correct by passing the original message and the signature, right? And if the result is valid, we'll see a check mark on the messages, otherwise we'll see like a cross mark. So let's see if it works. Sorry, this one. It's check mark. So it takes some time because of the IPNS being resolved. Hello. Let's wait a bit. Okay, I'm seeing Alan Shaw is verified already. So it takes some time at first because we are really fetching, in this case, Alan Shaw's DID document and checking if the signature is correct against one of his public keys. So it takes some time to fetch the first records. As you could see, there's no prompting. I wasn't prompted to authorize the signature because we have two different signature schemes. One is with your session private key, and the session private key is associated with the session, but the private key lives within the wallet. It doesn't live within the example shard, meaning that you are always in control. The app never sees any private key, okay? But the trick here is that session private keys are unencrypted within your wallet. But if you need more security, for instance, if you have a feature like remove a chat room, or create a chat room, maybe you need some degree of security, so we will ask to sign with the device private key. Because session private keys are child keys from the device private keys, so it's kind of hierarchical. So to sign with the device private key, we need to prompt the user, because he needs to put the passphrase or to unlock it, to be able to unencrypt the private key so that we can sign. And let's actually do something cool, which is whenever we type IPFS, okay, let's ask to sign with a session. So in order to do that, let's just copy this piece of code here that is below and replace with the previous line that we have. So basically, what I'm doing here is detecting if the message contains the word IPFS. If it does, I'm asking to sign with a device key. Otherwise, I'm asking to sign with a session key, right? Let's see if this works out. So,
one question. How do other users verify the session key? Is
I can explain. I will actually open the signature, and I will try to quickly explain to you after this. So, if we type IPFS, it prompts me to unlock IDM and to authorize the signature. So as you can see, like this is like a preview of what's being signed, and as you can see, like there's the text, and there's myself, the author. So if I authorize, in this case, I'm signing with my device key. So let me try to explain the signature scheme. So we have here like a console log containing the. Can you see it, by the way? So this is a message produced by the app. So it has like an author, an ID, a text, and a timestamp, and there's the signature. So the signature contains a few fields. The most important ones are the DID URL. So the DID URL is like the URL for the public key that is within the DID document. So the DID document is that one. So it should be my DID document. And you have the key ID that was used to sign, okay? And because I signed with my device private key, the derivation path, we use BIP32, the derivation path is root, okay? But if I type something with my session key, and if you check the signature, what we'll see is that it's basically similar, everything, except the key path. The key path contains not only the root, but something that points to the session public key, the key path that was used to derive the session public key from the device public key. So you take the device public key, you take that key path, and you derive the session public key based on the parent-child relationship. It uses BIP32, so if you are interested in knowing more, this is like an open specification for that. It's not something that we invented. So yeah, that's basically how the client is verifying the signature. So it's fetching the data document, it's checking, deriving the key, and checking the value against the signature. Sorry, checking the value against the message and the public key. That's it. So, and one last thing that I want to show is to actually prove that we are in control. So I'm going to go into Nomius. I'm going to unlock it because my idle time passed. And I'm going to revoke access to this app, okay? Because we already interacted with an app, so I'm going to revoke it. So if I revoke it, the session will be destroyed, right? So that got removed, and I'm logged out. right? So the session was destroyed, and because this type of bridge is like multi-directional, in this case, the wallet sent a message to the IDM client saying, hey, this session ID is no longer valid. So it automatically destroyed it, and things got updated automatically. So
it's up to the application to respect that revocation, right? To log you out.
is up to the app or to the spec too?
Yeah, no, I'm asking, like, is it the app that respects the revocation? Because I assume you could just stay.
Yeah. If the app itself denies to, like, let's say that it keeps the session for some reason, it won't be able to produce new signatures because the wallet is the wallet that produces the signatures, because the app never sees the private key. The app needs the bridge and needs to interact with the wallet in order to produce signatures.
Okay.
So the apps can't really do anything after, even if they keep holding the session, they can't really do nothing. And if they even do, the signature will be invalid because they couldn't be produced at all, right?
Are we talking about like the message signatures in this example?
So what, sir?
Are we talking about the message signatures in this example?
I already showed you, I think. It's like this.
Yeah. Okay, those. Okay.
This is signature scheme. Also, if you're more interested in knowing the exact process, we have a repo called IDM signatures. It's listed on our management repository. I will actually show you afterwards. So if you're interested, you can go there and see how the process actually works, step by step, actually.
Can you now like verify the other signatures even if you are not logging?
Yeah, I am, because the client doesn't depend of a wallet to a wallet for that, because wallets can be compromised, right? I can create a fake wallet that validates successfully every time. So the clients need to actually not use the wallet and be responsible for that, right? So I think that's it for the demo. What do you guys think? So one last slide is that we have like this very cool website. We did like in 3-4 days. So just go there. It's really cool. Like, it's just a presentation of Nomius. So if you're more interested, like if you are interested in knowing more, you have like a link here for the concept document that describes what we are doing here. And also you have subscribe feature so that we can deliver updates to you about the things that we are developing, new features, stuff like that. And also there's a link for this workshop if you want to, do the workshop by yourselves. And also we have a link for our management repo, which contains all the links for the code base so that you can actually see the code by yourself. So you have like all the repos here associated with the code base. So yeah, that's it, I think. We are already over time. If you have any questions, feel free to ask them, really. Okay.